Resistors are used to reduce voltage in an electric circuit and limit the current in electronic circuits, consumer electronics, automotive electronics, industrial systems, lighting, medical equipment, power generating systems, measuring instruments, and others. Replaceable wireless resistors are typically made from a blend of constituents. For example, carbon composite resistors are made from a blend of ceramic powder and carbon, which are bonded by resin. Therefore, in manufacturing this type of resistors, one of the main factors decreasing the number of defective items in terms of parameters, smooth running, electromotive force of inherent noise, resistance temperature coefficient, involves the increased requirements for the quality of constituents, their dispersionability, and homogeneity of the resulting blend. Ball mills are typically used to produce blends for resistor manufacturing. The process of grinding and mixing the constituents inside the ball mills may take up to 60 hours, with the drying time excluded. In addition, this type of mills has other disadvantages, such as large dimensions, high noise levels, and great power consumption. Based on this, GlobeCore has developed an innovative technology for producing a blend of constituents in the manufacture of replaceable wireless resistors. The technology is implemented by means of AVS Vortex layer machines. The operation principle of AVS Vortex layer machine involves the use of an electromagnetic field to mix the constituents and to process the resulting blend. The initial constituents, as well as the steel ferromagnetic particles, are placed in the machine's operation chamber. The chamber is surrounded by inductors that convert alternating current power into variable magnetic field energy. The magnetic field has an effect on the ferromagnetic particles, causing them to move intensively and randomly inside the chamber. Intensive movement of ferromagnetic particles ensures their constant colliding with one another, the operating chamber walls, and particles of the material processed. During this movement, the particles collide with one another, with parts of processed substances, and with the operating chamber walls. As a result, a whole range of effects occurs in the machine's operating chamber: intense impacts, high local pressures, a rotating electromagnetic field, magnetostriction, ultrasonic vibrations. Their comprehensive effect allows for grinding, activating, and thorough mixing of constituents to achieve homogeneous blends. Grinding in vortex layer machines occurs to such a fine degree that in some cases, cyclone separators are required to capture the finest particles of processed substances. The test results for conductive components made from compounds based on alloyed indium oxide indicate that processing in the AVS Vortex layer machine allows for fine grinding of constituents and producing a homogeneous blend for resistor manufacturing in a matter of minutes. The resistors based on this blend have a much lower electromotive force of inherent noise and a higher rated resistance value. This is due to the enhanced specific surface area of all the blend constituents up to 7,500 square centimeters per gram, as well as the increased activity of processed material. Comparing the performance of resistive layers made from the powders processed in ball mills, 9 hours of processing, and in vortex layer machines, 4 minutes of processing, indicates that the rated resistance value after processing in a vortex layer is 3 to 4 times higher. Thus, changing the content of conductive phase and the duration of its processing in the AVS machine makes it possible to produce resistors with the required parameters. In addition, compared to ball mills, vortex layer machines have other advantages. In particular, they allow reducing the electricity consumption due to a lower power requirement. Depending on the model, one vortex layer machine consumes from 4.5 to 9.5 kilowatts. Reducing the noise level, simplifying the maintenance, and narrowing down the production floor space through more compact dimensions. And what kind of equipment do you use in production of blends for resistor manufacturing? Share your experience of using this equipment in the comments section. More information on the GlobeCore technology and equipment for production of constituent blends in resistor manufacturing can be found by following the link in the first comment or visiting our website, www.globecore.com.